Recording. Okay, great. So we're recording now. I'll post these videos, and like I said, I'll give you all the links, and I'll let you know where everything you can find all these materials in a sec. But anyway, as I was saying, so this is the course description. So this course covers the theory and technologies related to deep learning. So usually I will try to give you examples using tools, but we're also going to try to look at the algorithms from scratch as much as possible. Now, keep in mind that you have a lot of encapsulation of code, right? So you have a lot of that. You'll have a function, and then that function is wrapped around, you wrap around another function, you keep doing that. So there's a lot of that code wrapping going on in deep learning. Okay, so a good example of that is Hugging Face. So Hugging Face, for instance, just uses PyTorch. But if you had to code, let's say, a transformer in pure PyTorch, it's not an easy task. But Hugging Face has just written a lot of code that wraps around all of that so that when you get it, it's just a function that takes 4 parameters. So it makes it a lot easier, as long as you follow their specific formats. Okay, so that a lot of that happens. So, code wrapping is a key idea that is very useful. And so that's what I'm saying. So sometimes we'll use the libraries, which means it's very high level, and we'll also try to look at the algorithms to go as down as we possibly can, right, at the lower level. Okay, not the C code, but we're still staying in Python, obviously. All right, so in general, the course focuses, as I said, on transfer learning. That's really the key. Now, hopefully most of you, well, some of you I know, you've taken 520 already. So 520 is the course before this one, where I cover how to code in PyTorch, obviously, and we do everything from scratch, right? At a high level still, but in PyTorch. All right, so this class basically assumes you know how to do a little bit of that, right? And so our focus is now to use, the concept of transfer learning. So before, just to give you some contrast, in 520, we took a data set and we took a model that had random weights, or the weights were all 0 for the neural network, right? If we're talking about deep learning, hopefully you understand that we're talking about neural networks, right? And so that's what we were doing in 520. We got an architecture, the weights are random or 0, we got some data set, we train it, and then boom, we have a model, right? Now, there's only so much that we can do with that. Unfortunately, because our data sets are small, we don't have incredibly deep architectures, et cetera, right? Transfer learning is different, right? In transfer learning, we take a model where the weights are no longer random. Okay, that's really important to understand. So now we take a model that has already been trained, hopefully by Meta, or it has been trained by Google or OpenAI, someone like that, right? So they have a lot of resources. They have a lot of very intelligent people. They have a lot of computing power, and they have incredibly large data sets. And this is all they do. Plus, they have a lot of money, right? And so they are able to spend 3 months training a model from random weights, right? Giving it all the data that they can, giving it thousands of GPUs, running it for months, right? And in the end, they end up with a model, right, that has weights, really good weights for doing things. And so what we do in transfer learning is, in contrast to 520, is that now we didn't start with random weights. We started with weights that are actually really good. Or we start with architectures that are already really good. Like they have been fine-tuned, and you know exactly what's going on there. And so in transfer learning, you start with these models that are already what is called pre-trained, and then you do an additional step called fine-tuning. So in general, this is what we're going to be doing in the class. We're going to try to leverage pre-trained models, fine-tune them for some specific task, and then use them. So this will give us a lot more power, because in general, our models are going to be much better, okay? Instead of you training a model that can detect if it's a cat or a dog, now that's an easy task to do. Okay, you can detect 100 different classes with a model. It'll say, oh, that's a bus, that's a car, that's a boat. But now you can extend it for other applications. Does that make sense? So that's the general idea of transfer learning. All right, 520 models with random weights, and you had 100,000, you have MNIST, right? Or you have Sci-Far 10, you had a very tiny data set. It ran on your CPU almost, right? And now these things, the pre-training will not run on your CPUs, but you're not going to be doing any pre-training, right? You're going to be doing fine-tuning, okay? So that's what I'll highlight today. So for instance, you guys know about ChatGPT. And so we're going to be talking a lot about GPTs. That's one of the central concepts in this course, right? But we'll be able to grab GPT-2 already. Okay, so GPT-2 has already been pre-trained, and so it's available in Hugging Face, which is one of the, the libraries, if you want to call it that, that we will be using to solve our problems. Okay, so anyway, that's kind of the intuition with transfer learning. And when I say transfer learning, it applies to any neural network. So it's not just for text, it can be for images or for any other problem. As long as the key requirement for it to be transfer learning is that you have a neural network, and when you start to use it for your task, it's already been pre-trained by someone. So we're going to learn about things like ResNet, which ResNet is a type of, if you've ever heard of CNN, so you guys remember CNN from 520, well, this is a super CNN, right? Incredibly deep, incredibly powerful. And you can just use it. It's already pre-trained. It already has weights, and all you have to learn how to do is how to take inputs and outputs. And the nice thing about this is you don't really have to get like the weights and then load them into your architecture. We're going to use libraries that already do that very easily because they've done a lot of code wrapping, which is what I was saying, right? So they've done a lot of this. And so we'll use several libraries. We'll start the semester with transformers, which in the syllabus, you'll see I used to start with fast AI and then go into transformers. I'm just flipping. So I'm starting with transformers now. So we're going to start with text, language, and we're going to end with images. That's the only idea. Okay, so I flipped it a little bit, but it's still this similar concept. All right, so anyway, so as I said, in general, the course focus is transfer learning. So just to give you a term, another term is fine-tuning, right? So this is the terminology of transfer learning. So we're going to start with our pre-trained models, whatever they are, and then we're going to fine-tune them for our task. And there are, in fact, a lot of models that we can grab already that already can do a lot of things. They can basically solve problems without fine-tuning, because you can go to Hugging Face and download a model that has been both pre-trained and fine-tuned for a specific task. So that means that you can just start using it. You know, Hugging Face, I'll show you what Hugging Face is today if you've never heard of it. And so we'll start thinking about that concept. Okay, any questions about that so far? Makes sense, all right? So as I said, we're going to talk about transfer learning, and in particular on the topics neural networks, hidden layers, issues with designing deep neural networks, so very deep neural networks. Obviously, convolutional neural networks are part of the underlying concept in these ResNets, basically. ResNet. There's also another one called BGG, and there's a few other variants. Now, there will be a few topics that I didn't cover in 520 that I will cover in this class, such as recurrent neural networks. So RNNs, the reason, I used to cover RNNs a lot, but then transformers were invented in 2017, and they kind of like killed RNNs. But there's still uses for RNNs for other tasks, like sequential tasks that are not language, could benefit from RNNs. So that's one of the topics that I'll just throw in there because I didn't have time during 520. We're also going to cover reinforcement learning, which is really important, and it is now relevant once again. Well, I mean, it was relevant for other things, but it's very relevant now for ChatGPT and those kinds of tools. So we want to understand a little bit about that. Also, we covered GANs in 520, but I wasn't able to cover CGANs, conditional GANs, so we will cover that one as well. And then topics like word embeddings, batch optimization. Word embeddings are a really important concept because GPTs require embeddings, right? And I think I gave a very quick overview of a GPT in 520, just like one lecture. Here we'll spend a lot of time. Okay, so we're going to build one of your mini projects will be to use a GPT and pre-train it. Actually, you're going to You're going to take some data, pre-train it, and then use it, and it's going to be your own tiny GPT. Okay, so we'll look at that, but also you'll be able to get GPT-2. Some of you may be able to get even better GPTs. They're available now on Hugging Face. So that's the thing. So we can, whatever Hugging Face has, and they're constantly making more things available, we can use. Okay, so I'll do some examples, and then when you do your projects, you can explore other solutions. All right, and then other special topics, whatever. The only one topic I will not cover in this course is stable diffusion. Those algorithms, I mean, there's just no room for it, and it's another complex item, right? So that's the one topic that I want to spend more time on the GPTs and everything, those ideas. All right, so that's basically the course description. Here's just the same summarized in bullet form. The course requirements, as you know, 520, or maybe you've had a machine learning course before, so you should know Python, obviously. We're going to do the whole course in PyTorch, okay? So that's one thing. But if you've done TensorFlow or Keras even, I mean, you know that they pretty much copy each other, so it's going to be similar. But the whole course will be in PyTorch, and the requirement is to do everything in PyTorch. All right, so usually the prereq is ITS 520, which is the previous course, or an equivalent class. As you guys know, 520 is like an intro to machine learning, so we covered everything. Knowledge of programming up to data structures, Python, and some kind of statistics course is at least recommended. Okay. All right, so I've talked about the class. These are the books. They're not required. I'll provide all the materials, but obviously I should mention, the classic Deep Learning by Ian Goodfellow. It has no code in it. It's just pure like mathematical description of everything. Python Machine Learning by Sebastian Rashka and Mir Jalili. That's a good one also in PyTorch. So I do. If you want to get, some students like to get books, you can. Otherwise, don't worry about it. I'll provide all the code on my GitHub that we do in class. And so I usually like to give you the code that I want you to use, and you just have to modify it for your own problems and data. Okay. Okay, so that's the same thing. So if you haven't realized already, the course focuses a lot on generative models, right? GPTs are generative models. They generate text, right? So conditional GANs are generative models. They generate images. Fast AI will allow us to, we'll also do other tasks, but in general, this course covers more generative models, whereas in 520, I did not really cover generative models, at all, except for the GAN maybe that we did. All right, the grading. So as you can see, 50% of your grade will be assignments, 30% of your grade will be exams. There will be 3 exams, exam 1, exam 2, exam 3, at week 6, week 12, and during finals week. And then the project is 20%. Remember, this may be several mini projects instead of one big project, okay? Because, we're going to be covering text in one task and then images in another one. So it's difficult to have a project where you mix both of them. Okay. Right, and this is the calendar, as I said. I used to start this course with images and then move to language. I switched it around a little bit. All right, so that's basically it for the syllabus. The only one thing I will say with homework, please submit your homework assignments on Well, on time, yeah, definitely. Also on Brightspace. And also, we're going to be doing a lot of things in Jupyter Notebooks, but I recommend, please don't submit Jupyter Notebooks. Instead, generate a PDF, either print a PDF or generate the PDF. Okay, that's the only requirement I ask. Okay. So yeah, so that's kind of the syllabus. I would say you're lucky to live in the age that you live. It's such a fun time. So enjoy the class. This is 5:30. It's an elective. So it has the students that are here chose to be here. You don't have to take it for your master's. It's more of a research class also. So there's a little bit more of the research component. So that's why there's a lot of little mini projects, okay? It's going to be things that are kind of more unique. There is no right or wrong answer per se. It's just more about getting things to work. Another thing that might happen, usually you do machine learning classes where a lot of things don't work. With transfer learning, things work really well. Okay, if something makes it to the Hugging Face platform, it's good already. You know what I mean? And so, or fast AI, that things just are, because things are now pre-trained, fine-tuned. You know, ResNet is not a thing that somebody came up with 6 months ago. It's 10 years of research, competitions, etc., until they arrive at the perfect architecture to do image processing with CNNs. You see what I'm saying? This is what we're talking about. You know, getting to ChatGPT took, well, 5 years of intense, crazy research and millions of dollars, right? Just to make it. So it's like you have the collective of people, software, competitions, money, building these specific things, okay? So keep that in mind. So things, you'll be surprised at how well things actually work. All right, so yeah, so that's kind of the syllabus. All right, so now let's go back to table of contents. All right, so I've covered these 2 modules. As I said, I'll cover the GPU Scholar. I'll give you further instructions once I get them. I have requested, I just haven't received it. Okay, so now today we're going to look at these 2 modules basically. Okay, these 2 concepts are actually really important. One is called RLHF. Anyone know what that stands for? RLHF? It stands for reinforcement learning through human feedbacks. This is how ChatGPT was trained. Okay? Up to 2 years ago, up to 4 years ago, we know what they did. 2 years ago, when OpenAI did what they did, nobody really knows exactly. But the consensus is that this is what they did. Because the problem is OpenAI hasn't released entirely how they did it. They've just given us a high overview, which is this. Okay, but they may have some secrets that they're not telling anyone. I mean, they're a company, right? So they can do that. So anyway, we'll cover this. This may be your project for the semester. Okay, so I'm showing this to you now. This can be a little bit challenging, but I'll kind of try to explain to you how you can do it. Okay, so we'll go over that. So this is one of the main topics. And then the other main topic is just basically Hugging Face. So we're going to start there. So the idea is that you want to be able to solve problems, right? So as I said, usually I will describe the, the transformer, etc. I'll go over that again, explain kind of how it works. But then at the end of the day, we want to leverage pre-trained models. So we're going to need some resource. And today, the main resource for getting GPTs or BERTs, transformers in general, is the Hugging Face hub, as they call it. So let's start there. Before I forget, so some of the resources for this course, I already have them here. I think I forgot to add the resources module. I'll do that. But basically, one resource will be this. So I brought this back from like the pandemic. I had this and I brought it back. It's just a course website. And it basically has links to the resources. Okay, so I have the GitHub here, which is, where all the code lives. I have the YouTube channel where all the videos will be posted. So if you ever miss, don't miss class, because you are, somewhat required to come to some classes, right? This is not an online course. But if you have to miss a class, or if you want to go back and view a video, I'll post all lectures and labs on the YouTube channel, and you can find them here. So probably click on that. Right? So it's going to give you the videos there. All right. The GitHub is this one. So you can click on that. And in my repo on GitHub, I called it Transfer Learning because that's really what it is. So that's the one where I will post like the official materials for 5:30. Okay, everything is here already. You can see all the code pretty much that we will do in the class. I've mentioned here, so LLMs, resonance, VGGs, YOLO, which is object detection, RLHF, and then we're using PyTorch, FastAI, and Hugging Face. So those are the main libraries, if you want to call them that. So FastAI examples will live here. If I do anything you can sometimes grab, let's say like a ResNet without Hugging Face or without FastAI, because PyTorch also makes these things available. So usually when that happens, I'll put them under algorithms, okay? And then it just means not pure PyTorch, but PyTorch, only PyTorch. YOLO, it's like a library. Hugging Face, as I said, is the other one. So all the code lives here, and you can always reference it from here. And if we do anything new in class, I will load it here. Then the RLHF, reinforcement learning through human feedbacks. This is also where I post the materials related to that. Okay, this would be like the state of the art. So the way that I would say is the evolution was deep learning, CNNs, right? Then, a few ideas like GANs, which is a very nice idea. Then transformers, right? And transformers are still the main algorithm. But to get transformers to really work, you have to throw in this concept of reinforcement learning through human feedbacks. It is actually the thing that gives it the wow factor. If you grab a GPT-2 or even a GPT-4 or whatever is the latest, it's okay, but you ask it a question and it's just going to ramble, right? The thing that makes it be able to answer a question is to do a fine tuning through RLHF. Does that make sense? So what I'm saying, and that's a complicated technique, right? So it uses reinforcement learning. So that's why I will cover reinforcement learning in this class, just to give you, we'll do that with games and simple examples. So at least you have an intuition of how that works, because it is much more complex later, okay? So to give you an example, to get a chat GPT, you start with a really good pre-trained GPT, like GPT 3.5, which means you use 10,000 GPUs, millions of dollars, a team of 1,000 engineers, right? And pretty much all the data in the internet and all the books in the world. You see what I'm saying? So that's what you want, right? It's really large and massive, and that only gives you a GPT-4 or a GPT 4.5. It's pre-trained. So one good way of thinking about it is, okay, it speaks English, or the language that it was trained on. Sometimes they're trained on multiple languages too, but it speaks. Now, if you ask it a question like you see in, what do you think about politics? It's not a very good answer that you get, right? And that's because you still have to fine tune it. And the fine tuning is now this idea of reinforcement learning through human feedbacks. Okay, so we'll talk about that procedure and how that works. And then, yes, you get a model that works. So I'll use the example of a math GPT just to make it fun. So a math GPT is what? Is a GPT that you give it a high school word math problem, and it gives you the solution. It doesn't give you equations or anything. Remember that everything still needs to be words, sentences, etc. But you can give it a nice high school math problem, and it should give you, all of you went to high school, so you know exactly what I'm talking about. You had math problems, all right? So that's the example I will use in class, usually. Just how would this work? How would we make a math GPT? Okay. And so I'll kind of motivate some of the ideas with that. Got it? All right, so that's basically that concept here, but we won't always need to talk about that. Sometimes we'll start obviously with Hugging Face and very simple transformer examples, okay? So I've given you the GitHub, I gave you the YouTube channel, and I gave you the link, right? So I think that's pretty much all the resources. So let's go back then to the table of contents now. Okay. So let's start here, Hugging Face. Okay, so what is Hugging Face? So there is basically all the math, right? So there's all the people that created deep learning and optimization and created the loss functions and all those things you've learned about, right? You remember how to train, the loss functions work from 520, all of it. So that's the math. And then this is implemented through PyTorch, right? And you have a low-level PyTorch API that I can show to you where you can create the transformer, right? You can create a deep learning construct called the transformer, okay? However, PyTorch has created code wrapping, right? So that you don't have to write the transformer at such a low-level API, right? So then you get, for instance, if, transformers use what is called the attention layer, right? So you could create the attention layer from scratch in PyTorch, or you can just use the attention layer that they've already made. And it's like a function or a class, right? So that there's code wrapping there that has been done. And so it makes it easier to develop a transformer, okay? Then there's Hugging Face. And what is Hugging Face? Hugging Face tries to make things even more easy, right? So, now they do more code wrapping of their functions. And so they make it so easy that you can just say, I want a GPT-2. And it's like one line of code and boom, you have a GPT-2. And then you want to say to that, I want this GPT-2 I'm going to give it some input and I want it to finish the sentence. And it'll do it. And it's 2 lines of code. Okay. So that's what Hugging Face is. They created basically open source, by the way, an open source, code base. And that's the whole, and they call it transformers, right? So that's the library that we will be using, right? So the environment will be the same as in 520. We're going to install Anaconda. It should work on Windows. Then we're going to create an environment. We're going to install our transformers library, etc. And then we're just going to invoke some of these. So during the second half of today, we'll go over that. I'll create the Anaconda environment and all of that, and we'll hopefully get one model to work. It shouldn't take that long, hopefully, because these things can run on the CPU when they're doing inference. And what I mean by that is there's pre-training, right? And then there's fine-tuning, which is all training. Pre-training usually is massive amounts of data. Fine-tuning it might be just 100,000 sentences. If you remember MNIST, it's 60,000, right? So yeah, it's reasonable. You have a sense of that you can process that with a CPU. But we can use Hugging Face just to do inference, which basically just means, I'm going to give it some sentence and it's going to complete it. Does that make sense? And that should definitely run on your CPU. The models are still big. So keep in mind really quickly, by the end of this semester, if you just download a whole bunch of things from Hugging Face, you'll be at 50 gigs or 100 gigs of space on your hard drive. So watch out for that, okay? Because the models can be big. I mean, GPT-2, I think, is, I don't want to exaggerate, but I think it is half a gig maybe. Yeah. So just keep that in mind. All right, so let's take a look at, so as I was saying, so Hugging Face, the last time I checked, is a company. It's about 100 people, I think, at least the last time I checked. And they basically have developed this module called Transformers, all open source. You can literally go and look at all of it. There's nothing they're hiding there. And basically it's all Python, and it works with PyTorch and TensorFlow. So it's not just, and it's just code wrapping, right? So they're very good at that, and they make very efficient code. All right. And so they're a company, I believe they're for profit is my understanding, but their goal is to make these models available. So that's this will be the thing that we'll be using a lot this semester. So it makes sense to show them. So you can see here, this is Hugging Face. It's got a lot of models. In fact, all of you can go in right now, create an account, and you're on the Hugging Face repo, right? And then if you do something in this class that you're very proud of, like training a model, you can load it, my model, whatever it is. You need to follow some of their guidelines and then share it with your friends. So then that way other people can just download your the model that you train and use. Okay. So that's what models means. There's a lot of models in here. A lot of them are transformers. My understanding is they do have other things like Stable diffusion models are there, or those funny, you write something and it generates a cat on the surface of the moon and they're a Jedi Knight or something like that. So all of that may be available there. They're constantly updating this. You don't need to have a spy at OpenAI, right, to know what they're doing, because Hugging Face somehow knows what they're doing already. And they're always just trying to implement it and make it available. So it's really interesting how that works. So I follow them a lot because they're basically telling me what's going on. Data sets, obviously we need a lot of data sets. That hasn't changed really from 520 or any other machine learning class. Usually the hard part is not actually understanding how the transformer works, right? Or coding it, because remember, once you do it, you pretty much just have to tweak it here and there. In fact, the original transformer from 2017 has changed very little since it was invented. This is like the astonishing thing. Either nobody understands it and they can't modify it, or it's just a perfect thing that it just consumes everyone's time. But it has had minor changes from the original 2017 one, even today, right? So that's that's a common thing in machine learning. You reuse the algorithms quite a bit, but the data is another story, as you know, right? If you have a problem, you have to take your data, spend a massive amount of hours just to convert it to the appropriate format that will fit into your models. And that's really what's challenging in anything. For instance, in this problem with reinforcement learning through human feedbacks, I'm not even going to attempt to explain how the data set is converted to what is needed right now, right? This might be it takes us a whole semester to understand that. But I will talk about the other concepts just to give you the gist of it. So anyway, Hugging Face is what we will be using. We'll be using it through the Transformers library, which will be very easy. And then we'll be able to download models. We'll be downloading BERT models or GPT models. I think I've mentioned this already in 520, but I'll once again repeat it. We will spend a little bit more time this semester on the BERT models. If you remember, basically, a transformer is made up of an encoder and a decoder, right? So it's got those two, which are actually very similar architectures. And basically, it was created like that to do language translation. That was necessary to go from English to Spanish, or one language to another. But as it turns out, people have taken just the encoder part of the transformer or the decoder part of the transformer for their various applications. So encoder parts of transformers became the BERTs, right? The BERT models. And then the decoder parts became the GPT models, right? So the GPTs. So GPT means what? It means generative pre-trained transformer. Okay, that's what it means. And like I said, we'll take a look at that. Like I said, we'll spend time on the algorithms just because I like to to spend time on that. But in general, and I do want you to do, I did this last semester. I had students use the from scratch code and pre-train it with their own data. So they did, like, some students did Harry Potter. Now, it's not going to be as good, obviously, as even GPT-2, because it depends on the amount of data and time that you spend. But you could see that it started to speak like Harry Potter stories, or it started to speak like Rick and Morty stories, or Shakespeare, or something like that, right? So, it's up to you. It'll just be a homework, but it's something that you can try, and it's not bad. I mean, if you have a GPU, it takes 20 minutes with 1 or 2 books, so it can learn pretty quickly to do interesting things. All right, they have other things, other products that they sell, but in general, you can see they have a lot of the tasks that they can do. So this is, you can see it's already mentioning Llama and Mixtral. I don't know if you guys actually follow these things, but this is state of the art. So the way that it works is you always had GPT-2, GPT-3, GPT-4. That was by OpenAI. As OpenAI became wealthier and was making money, right? They they wanted to protect those resources, so they were not making them available to anyone. And so what happened is, what's funny about the big seven, right? The big seven IT companies like Google and Facebook, Meta, right? So they compete against each other. So in this case, what happened is, I believe GPT-4 was, or GPT 3.5 was not made available, one of them. So what Meta did is that they developed their own GPT and they call it Llama. Okay, so whenever you see these llamas, like tiny llama, llama this, llama that, it's basically the open source version of like a really good GPT that is used for Chat GPT. Okay. Now, Mixtral is the new thing. You can see it's already there. And, you know, it's basically 27 days ago, right? It was loaded to the hub of Hugging Face. So it's the latest entrant, right? So basically, it's called a mixture of models. So I believe they're using several models, and they developed this solution. This is out of Europe and France. They developed this, and it's supposed to be really good as well. So there's a lot of like attention being paid on it. So there's like 3 competitors right now, possibly, like OpenAI's GPT 4.5, whatever it is, which is closed source, so we don't have access to it. Llama from Facebook, Meta, which is open source for anyone to use for research purposes, not for business. And then Mixtral, I don't know. It's a very new one, so I haven't looked into it, but it's supposed to be very powerful. All right, so that, you know, these are, you know, basically the Hugging Face environment, as I said, and, you know, a lot of things that they do, companies that use it. And then here is like the things they have. So they have diffusers, transformers, Ph.D, which is a new solution that's become very popular. So there's basically different ways that you can use this stuff. So some people just want to download a pre-trained or fine-tuned model for some specific task, right? This is what we will be doing in this class. We'll do that for sure. There's people that want to pre-train or fine-tune on massive amounts of data. So they encounter there a specific problem, which is that you can't really train these models on just one GPU. You definitely can't train them on your laptop, on the CPU. It's just not possible. But some of you that may have GPUs, okay, you know that you can do more with it. But these companies, you know, companies or entrepreneurs, right, that are trying to develop these very powerful models run into the problem that the only way that they can do it is through multiple GPUs. So for instance, one solution of NVIDIA nowadays is to build a computer that has 8 GPUs. And that's kind of just to get started, right? Or the cloud services that they have. But programming for multiple GPUs is not straightforward. Okay, you need tools for that. Like Ph.D is one of the things that what is it? What's the name? Ph.D. Yeah, Ph.D is one of the solutions. LoRa is another one. So there's a lot of solutions for that. Okay. However, that's as I said, if you come across that, it's for like multiple GPUs, massive amounts of data. We barely have a GPU here for the class. So we may talk about that a little bit, but we're not going to get into it. Okay, not likely. Any questions so far? All right, so anyway, so that's Hugging Face. I think hopefully that gives you an idea. The name just comes from the little emoji Hugging Face. Okay, so their library is called, as I said, Transformers. So I'm going to close this. Okay, all right. So I don't think we'll come back to their website. We don't have to go to their website to download a model. Instead, what we use is the Transformers library, and then from Python, we will download our models to do things, right? So right now, I'm not going to run any code. I'm just going to talk about things during the second half today. We'll set up the Anaconda environment. So hopefully you guys, if you haven't done so already, download Anaconda to your laptops. Oh yeah, go ahead.
Are we still using 3.7?
Python 3.7, that's a good question. Actually, for the RLHF, which I haven't talked about, it requires 3.8. But for some examples, we can use 3.7. So you'll have to create multiple environments here. Remember, this is more research than 520 was. So that means more bleeding edge. And that means more like, it doesn't always work. It's finicky, right? So we gotta, but Anaconda, as you know already, is very good for that. So we'll create multiple environments. So I haven't created the environment for this class, so I'll do it today in class. And you guys can follow along. So definitely download Anaconda. That, if you don't remember, let's go to the, did I close the website? I may have closed it, sorry. So under the resources here, I added Anaconda, right? So if you, oops, okay, or not. Click on this one. Right, so this is the environment. This works on Linux, Windows, Mac, right? So just go on here and download the Anaconda environment. It's just, double click, that kind of thing, install it. And then I'll show you how to get to the, once you've installed it, I'll show you how to get to the command prompt of Anaconda, set up an environment with Python 3.7. We will need Python 3.8 for RLHF and, that kind of thing. Yeah, please go ahead.
So when you do the fine tuning.
Yeah.
That's still considered training, right?
Yeah, oh yeah, it's training.
So the weights still change. So
I'll show exactly. That's actually a very good question. So that means one way of thinking about it is like this. Let's say you have 12 layers of the neural network, right? What you need to do is you need to freeze a percentage of the layers and leave the other layers not frozen. So what happens there is that when you do the training, the frozen layers do not get updated. You see what I'm saying? So let's say that I have 12 layers. This is actually an example. So 12 layers, and I'll say that the first 9 should be frozen. But the last 3, right, are the ones that are going to be updated by the fine tuning. So then when you start doing the training, only those last 3 layers is get weights that change, the other ones stay as is. So that's how you do it. Does that make sense? And it's very easy, actually. So you'll see the code is actually straightforward. This is one of the examples that we're going to cover. Yeah, go ahead.
Quick follow-on question.
Yeah.
So when you're actually using the ChatGPT,
Yes.
then you ask a question, you get result, you say, no, that's not the answer, that's not the right answer.
Yeah, yeah.
So then you go back and forth, and then finally you'll get it right.
Yes.
That process
Yes.
there, is that still fine tuning, or is that no longer?
That's reinforcement learning through human feedback. So you literally just described what that is.
I see.
Except that you don't do it like a GPT generates something and it gives it to you, and then you give me the feedback, and then I generate another one and I send it to you. This is how humans think, but that would be inefficient because it's too much back and forth. So you do it more like, first you look at some data and you rate it. So it's like you say, okay, this is a good one, this is a bad one, this is a good one, this is a bad one. And that's the data that you give for the training. You see what I'm saying?
So that's the training, but when we're actually using ChatGPT
Yeah.
as a user, when that happens as a user.
Oh, I see what you're saying. Yeah.
So the weights that in the back end, they don't get updated anymore.
I would say they're not. Yes.
It's so that's no longer fine tuning. That's something else.
Well, that's what I would do if I was doing that. Is I would want your feedback, but I'm not going to update the weights like in real time. I'm just going to save that data and start creating a new data set. Because it's the same thing. You looked at 2 things and you told me that this was better than the other. So I don't want to just use that one thing and give it to, it's too expensive to do that. And so what I do is I just save it in my database or whatever it is. Once I've collected 100,000 of those from people all over, I create a new data set overnight. I go to the cloud, pay a lot, for a whole bunch of GPUs, and then I do the process. Yeah. Although fine tuning actually doesn't require that many GPUs because it's maybe 100,000 feedbacks. Yeah.
What's driving that, that interactive work, the interactions between the user and the, what we're seeing on screen, because you can still have a conversation to help them, like this. They call it prompting.
Yeah, but that's different because that's like a model that's trained. So they still want just the GPT to do everything. So they help it by giving it tools, but at the end of the day, you want to see how much you can get out of just the model itself with the weights. So you may be giving it like text, and then based on that text, it's got like a little bit of context. It's keeping track of things, but it's still collecting text and generating text. At the end of the day, the GPT takes some text and gives text. Give it text, other text. So they don't want to like put rules and heuristics in the model. They just instead, if you say, I didn't like this, that just gets added a little bit to the text. And they may add some other things, but it's still generally just text goes in, text comes out, because you want to maintain almost, it's like saying you want to maintain the purity of the GPT model and just see what you can get out of it without messing too much with it. You're trusting like just the weights. That deep learning itself can solve the problems. And so this is the approach that people are taking. Does that make sense? Yeah.
So my understanding is that it's generating something based on probability. So every time it's taking in the new information as
it's the neural network. It's not, there's no probability stored in a GPT.
So you ask the same question every time it gives you slightly different answers.
Because it's a generative model. Yes, you're right. It's not a probability. You technically, it's just a neural network, right? It's just the weights and how they are. I know what you're thinking. What is the more likely thing that it should say? That's probabilistic. I agree, but it's not a probabilistic model. It's just based on the network architecture, like the transformer. If you remember, like we talked about in 520, and we'll talk about it again. We'll see the architecture. There's no probabilities in there. It's more like the embeddings of the words are capturing a lot of insight, but that's just the values that it's learning for an embedding. Okay, but there's no, I used to also think, okay, let's get the probabilities out of this, but there's no such thing in a transformer. It's just the network architecture. Okay, so this is why it's really good to look at the code, right? To understand how the transformer works, which is one of the things that we will do. I will go back again to kind of that lecture, but spend more time on it, on the whole architecture of it. Remember, it's complicated, right? And you will train with some text data to get your transformer to predict things. Okay. Any other questions? All right, great. So yeah, good questions, right? So there's a lot of things there. As I said, we are going to take the approach of using basically Hugging Face transformers. So let's go back to the module here. So we've discussed this. Let's go back to the table of contents actually. So there are the two first modules will be, as I said, these two. So this one just goes into simple examples of using transformers, using actually the transformers module from Hugging Face. It's very simple. So whereas before, if you were to train a transformer from scratch, your Jupyter just for the transformer architecture, if you remember from 520 was, I don't remember, but 100, 200 lines of code possibly, right? And that's just to have the architecture of the transformer, then we have to do all the other steps. Here, it'll be 10 to 20 lines of code because we're leveraging Hugging Face itself, okay? So that's kind of what I'm going to show, just discuss a little bit right now, give you an idea of how it works, and then we'll play with one or two in the second half. All right, so I have some, I've loaded already some here. Okay, these are all the examples that I loaded that we'll be covering, not necessarily this week, but you know, in the first few weeks. Okay, so whenever you see that they have names like Albert, Robert, Bert, they're all variants of the Bert model. All right, so people in AI for some reason like to give things funny names. So either llamas, alpacas, or you have Berts, you know, Roberts, etc. Okay, so all of these are BERT models, so they're usually the easier ones, right? You know, last year they were more dominant, I would say. Now the GPTs are more dominant, obviously, because ChatGPT like blew everyone's mind. So, but there's a few ones that we can play with, like BERT, Albert, BART is a variant. This is just a simple example. There's Electra, Roberta, which is one I've used somewhat. And then there's a few other things that we can look at, like specific tasks that you can do, specific concepts, okay? So we can take a look here in the Jupyter Notebook. I just want to give you right now, we're not going to run this, but I just want to give you an idea of the basic pipeline of how this works, right? So, you know, you need to install transformers. So this, imagine we have a Jupyter Notebook. So you do your pip install transformers, right? The Jupyter Notebook should be at least Python 3.7, 3.8. And then you can see that really the way that they've wrapped the code around PyTorch, basically you really can get away with just these three modules here. You have, so in this case, you know, every model is a transformer, but it might be different in some way. The architecture is a little bit different or this and that. So they may create modules specific for the type of transformer. So as I said, remember, transformers have an encoder, a decoder. If it's a decoder, it's a GPT. And if it's an encoder, it's a BERT type model. So here, obviously, if I look at Roberta, right, it's a BERT model. So it means it's using the encoder, okay? At some point, we'll discuss the code behind the BERT models, okay? But, you know, that's the idea. So you need at least three things to get this thing to work. We're using Roberta, so you need the Roberta tokenizer. That's one item. You need the Roberta model. That's one item. And then they also created this thing called a pipeline. If you remember in machine learning, we discussed this idea of pipelines quite a bit, right? So basically you have inputs and outputs, but in the pipeline is all the steps that happen. So they have a module called pipeline, which allows you to very easily just pick a tokenizer, a model, and then whatever you want to do with it. That's it. So those three arguments give you a very powerful solution already for specific tasks, right? So the model, Roberta, is just an encoder, right, of the transformer architecture that has already been trained, right? We'll talk about how this is pre-trained, right? But the first BERT model, I believe, was made by Google. Then Meta made another one, which I forget. Roberta, I think, is Meta's solution, actually. And it's the exact architecture as BERT, but maybe more data and some things like that. So as I said, understanding how BERT models work and encoders is a different lecture, right? That will take time. But for now, Roberta is the model. It's a pre-trained encoder. The weights are there. It was trained with a lot of data. And then you have the tokenizer. So the tokenizer is really important, right? Because transformers, neural networks, all they are is numbers. So you don't actually know the word the does not exist in the transformer or car or boat, right? There's no text in there. What's in there is numbers. 3, 17, 55. This is something we did in 520. We'll do it again in this class. So we need these tokenizers. You can almost think of it like a dictionary. You have IDs, and then you have the corresponding word, right? So you have this idea of how to encode. So I have the cat is sleeping. The cat is sleeping becomes a series of numbers, you know, 17, 3, 5, 36, whatever it is that go into the transformer. Does that make sense? So the thing that controls that is the tokenizer, okay? And there's various ways of creating tokenizers. So for instance, the way that we did it in 520 is we did the letters, right? I think we did 65 letters, uppercase, lowercase. Each one had an ID. That's our tokenizer. Not the greatest, but simple to understand. Other tokenizers can have, you know, these are the tokens. 100,000, 500,000, whatever. And they're not actually words usually, but instead they're almost the equivalent of syllables, although they are not syllables either. Okay, instead you create pseudo syllables called subwords using algorithms like BP and sentence piece and tip token, and there's libraries for that as well. Okay, but our very basic example will just be letters to keep things simple. So you need a tokenizer always because it has the words corresponding to the IDs, and it has to be the tokenizer that corresponds to the model, right? Because this is how it was trained. You can't use the BERT tokenizer on the Roberta model or a GP, unless that's how they were trained, because otherwise, the ID 17 will not correspond to that, and so you'll have a problem. And then you have this other concept called the pipeline, which, like I said, is really nice because it's just meant to be like a class or a function or something, and just takes parameters like the tokenizer, the model, the task. In RLHF, you'll see that what Huggin Face did is to train something as complicated as reinforcement learning through human feedbacks. They really just want the model, maybe a reward function, which is another model, and the data set. And those are all you have to worry about. But this is an abstraction created by Huggin Face, right? It's very specific. Things have to be very specific for it to work. Okay, but we could train, in theory, a math GPT just using that. Okay, so we'll talk about that a little bit later. But for now, this is basically a Huggin Face environment. Notice that there's also Panda, so you can use other libraries, right? You can use whatever other resources you have, and you're just leveraging the transformers module, which is very stable, and it's pip install transformers gets you it. Once you complete that, then you basically the basic approach is something like that. You're going to instantiate your tokenizer and your model in your code. Here in your Jupyter notebook, you can see you say something like Roberta tokenizer, right? Which is this one over here, this module, and then from pre-trained. And then you say whatever you want, because although it's a Roberta, there can be several versions of Roberta. There's Roberta base, Roberta large. What do you think that means? Roberta base, Roberta large. One is bigger than the other. You guys maybe hear this a lot, 7 billion parameters, 65 billion parameters. What that means is that some models like Robertas, BERTs, GPTs have more weights than others, right? Like Llama, for instance, there's a 65 billion parameter Llama, but it's really large. It doesn't really run on laptops. So people wanted something that quickly can do inference on a laptop. So there's Llama 7 billion. It's got 7 billion parameters, much smaller. Does that make sense? Just remember, just GPT-2, I think, is 0.5 gig already. So they get pretty big. Okay, so anyway, here I didn't select Roberta large because it can break my computer, right? So, and then it won't run. So I'm trying to do demos that work, and so Roberta base is good enough. This is way better than any BERT you can train, I promise you, because you don't have the amount of data or GPUs that they use to develop. There's a paper for the BERT model, how it was trained. So I will make those available. And as I said, this class is more of a research class. So we'll have to read some of the papers, not all of them, but we'll have to read some of the important ones, like the original Vaswani paper, the BERT paper, the GPT paper, and a few others here and there, the RLHF paper, just the key ones that are like very important for all of us to work. Got it? Okay, so anyway, so here I'm showing you create the tokenizer, you create the model, and then now, so you can see it, it downloads the data over here. Then you have the tokenizer needs to convert the data into the integers, right? So here, for instance, I can take the cat is so sad, or whatever text you want to give it, right? That's your input, goes into the tokenizer. You tell it to return a PyTorch tensor. So you sometimes have to specify whether you want to use the backend of PyTorch or the backend of TensorFlow, okay? And so you give it text, give it to the tokenizer, and now you have your encoded input here. You see that? This encoded input then goes into the model, as you can see here, and then you've got some output. So basically at this point, you've given this BERT some inputs, and it's going to give you some prediction, whatever it is. Now, there's a lot of variants of getting the model, because you can choose, okay, I want a model that just does the classic BERT stuff, or I want a BERT model that actually just gives me sentiment scores. There's in the Hugging Face hub, there's a lot of BERTs. And one of them, for instance, was trained to read a text and say is positive or negative, right? So you can select many variants. But in general, this is more of the basic one. So you can see here, when you do the model, it gives you now a prediction in BERT. And then when you print it out, you can see it's just basically a whole bunch of numbers. Do you see that? So that's the basic example. Now over here, we can create the pipeline, right? Which is the other construct that you have. And you have this idea of fill in the mask. This is one task that you can give for a BERT. Okay, we've all done this when we, in school, right? We had fill in the blank in quizzes where they gave you a sentence and you had to fill in. That's the same idea. This is actually how BERTs are trained. BERTs were trained where you gave it a sentence as an input and you gave it the exact same sentence as an output, except that you would like hide one word randomly. So the car is going really, and you blank it. And so the model learns to predict what it should be. So it should say fast. It shouldn't say the car is going really sleep. That would be incorrect. So it learns the correct things, right? So BERTs naturally are very good at filling in the blank because that's what they were trained to do. But at the end of the day, what you're capturing there is the context, right? That if I see the car is going really fast, or really, it should be fast or slow or something. Okay. So anyway, that's, you do this line pipeline, fill in the mask, you select the model Roberta base here, the tokenizer, and then fill in the mask. You create this idea. So now if you go over here, notice how straightforward it is. You say fill in the mask, where you say the cat is so mask. You have to, so the transformers have these special tokens, right? So there's the subwords, and then there are special tokens that they have in there, like the CLS token, padding tokens, separator tokens, and these mask tokens, which are basically meant to hide something. But it's a prompt, if you will, for the transformer to know what it should do, right? Which is to fill in the mask. And so here you can see, once you run this one with a pipeline, unlike this one where it gave you numbers back and then you have to use the tokenizer and decode them back, now the pipeline takes care of all of it. And so you just get this object fill mask, then you run your sentence through it. Then we use a pandas data frame just to display it nicely, and boom, there you go. That's your answers. You got scores, you've got the predicted token, and you can say, so what do you think about this transformer? We said the cat is so, and it said the cat is so cute, the cat is so sweet, the cat is so beautiful, the cat is so handsome, the cat is so funny. So apparently, I don't know. You can judge whether you think that those are good or bad answers, but they are Roberta's answers for sure. Any questions? So that's it. I mean, that's literally an example of this. And here you can see the tokenizer has special terms like mask token, where it tells you what it recognizes as the mask token. Remember that this is not just a transformer in the pure sense, but there's a lot of code wrapping that has gone around so that it's easier to manipulate. And this is also Hugging Face solution. Okay, so we're using their pipeline, we're using their tokenizer, and so on. But this makes it nice. Okay, this makes it really nice. Any questions here? All right, so as I said, we'll do more examples of this just to kind of get a gist of how it works. We'll come back to these. Let's go now to I want to show you the other idea. So that was Roberta, which is a BERT. Now we're going to look at a GPT, right? So a GPT such as ChatGPT to get a feel for how that works. GPT-2, it's so, what can I say? Old, I guess, that is pretty much like an eraser or a pencil, right? It's everyone will use it. Here's how I can say it. It's the hello world of GPTs. That's what it has become, right? So GPT-2, you will see it everywhere as the hello world of how to get started with GPTs. That is literally what it has become, because so much code, especially at Hugging Face, has been developed around GPT-2. So everybody that's doing anything, and I would recommend, even if you're going to use Llama or something, start with GPT-2, because you can benchmark it against a whole bunch of things, know that you implemented things right before you start taking out GPT-2 and plugging in a more advanced, like Llama, for instance, which is more state-of-the-art. All right, so so here in this set of examples, I had mostly like BERTs. Now let's go to the back to Brightspace. Okay. All right, so as I said, this week and next week, we're just basically going to focus on these two modules. So this other module is really important. You know, I imagine that most of you, your main interest nowadays is ChatGPT and all of that. So I wanted to show that today, you know, instead of waiting a whole semester to talk about it. All right, so this is actually, I have several things in here, several examples of how it works, okay? But I'm going to start with this repo RLHF because I think it's a nice view of how this, how you can visualize this thing. So let's say that you are an entrepreneur. You just got your startup, you got some money, and you want to build a ChatGPT because you think that's how you're going to make your fortune, right? So how do you get started with that? So obviously you have the problem of what you're trying to make, and then you have the pipeline. How do you build it? You know, how do you do the things that you want to do? So what I'm going to discuss is like a very basic way that you can think of it. So first you need a problem, right? So here I have a problem. I have a couple of problems here, but let's look at problem 2, which basically means I want to build, this is the example that I'm going to use. I want to build a math GPT. So what that means is I'm going to build a GPT for solving math word problems at a high school level, okay? At a high school level. So what do I need for that? Obviously, I need high school level problems, right? Where I have the word problem and the solution all in words, okay? All in words. So there's a data set for that called the GSM-8K, okay? This is developed by OpenAI. You can see that OpenAI's GitHub, and they're grade school math. Now, I think there's a paper for that as well. Now, this data set only has, guess how many, all right, let's say that you're starting this company. I want to know how many, so there's a problem and a solution, right? This data set, how many do you think you need? How many pairs of problem and solution do you think? This GSM 8K, right? So it's for a very powerful large, remember, I haven't said this already, all these things are called large language models. So it's for a very very powerful large language model. So my question to you is, how many problems do you think you would need? And you said 1 million? A few billion. High school level a few billion high school level. Okay. All right. And you say 2,000.
Up to 1,000.
Up to 1,000. Anyone else? Okay, so think now, what are we doing, right? So are we going to pre-train? Remember, this is transfer learning, right? So this is important. So it's transfer learning. Are we going to pre-train or are we going to fine-tune to develop our model that can become a math GPT. Fine tuning, okay? So if you're saying fine tuning, immediately you know something very important. You don't need as much data as in the pre-training stage. You see that? In the pre-training stage, you're going to teach it how to speak English. In the fine-tuning stage, you're going to teach it how to solve high school level math problems. You see, that's a good analogy that you can think of. So now I ask you the question again. How many math problems do you think, pairs of problem and solution, do you think you need? Thousands, right? In fact, it is right there. GSM 8K means 8,000. So GSM-K has 8,000. Now, this is really important. They are high quality. This is not like something that was done in an automated fashion. In fact, OpenAI spent a lot of money hiring people. You know, we work at universities, so we have a lot of students eager to help us out sometimes, but OpenAI, which is a company, has to pay. And so they paid a lot of people to develop really nice, and they dropped problems. Like sometimes they looked at a problem and the solution and they just dropped it. So this is really high quality. And it's a data set that's available for everyone to use, okay? So this is important, right? So you would fine tune your model with this, okay? So you still want to know kind of how you would do it, right? But we know this already, right? This is the problem that we're trying to solve. So then the question is, I need a GPT, right? I need a GPT to start. That's the pre-trained model. That, if you're an entrepreneur, some companies do it. They, you know, for instance, I just heard that Chase, JP Morgan, they built something they call Doc GPT or something like that. I don't know where they got their pre-trained model from, but because they're a company, right, and they want to own this as a product internal, they may have pre-trained it, but they're JP Morgan, right? So they can probably spend a few million, hire some experts in a cloud and train and do a pre-trained GPT for themselves. For other people, you can just grab one of the available ones, such as GPT-2, GPT-3, or Llama. Yeah, go ahead.
I think OpenAI now is making their APIs available for people.
APIs?
Yeah, they are launching hundreds of APIs for people.
But we have to use their API to interact with their model, right?
Right.
But don't they charge money for that?
Yeah, yeah. I'm just saying Chase could easily just grab one.
Oh, you think Chase just, but what I heard is that they would, oh, I also heard Bloomberg, for instance, created Bloomberg GPT.
Yeah,
And so the advantage of that is that you don't have to go through the OpenAI interface. Remember, you're kind of at their mercy. At any moment, they could just say, you know what, we're not going to provide the service anymore, and then they disrupt the company. So I think companies that can afford to hire as a consultant, Ilya Sutsketer or you know, Andrei Karpathy or something like that, they can build one of these models. I mean, if they're willing to spend the money, right? Because they don't have, the thing about this is you don't have to invest in creating a data center. You can go to Azure or NVIDIA or something for 3 months, spend a lot of money, run the data, and then you have a GPT. So if you have the millions of dollars to do it, because it's a lot of 3 months of GPU time in the cloud and something. You see, but so it just, I don't know, the business, you're a businessman. So if you're a CEO, you have to make that decision. Do I want to depend on OpenAI APIs, or do I want to build my own? And I develop that in-house knowledge, and so I can, you know, it's up to you. But certainly in this class, you know, I can't ask you guys to go spend money on OpenAI, right? So we're going to try to build things from scratch, leveraging Hugging Face and things such as that. Okay. All right. So it's 6:20. So we're going to take a 10-minute break. And then we're going to continue with the class and just continue developing the ideas of the course. Okay. All right. So I'm going to stop the video.